Hello viewers, this video is about basics of electricity. It should be beneficial to all the students and knowledge seekers who are looking for a strong foundation on the subject of current electricity and basic electrical engineering. So let's begin. The flow of presentation will be with conductors and insulators, their basis of categorization, the concept of electric potential and electric current. Conductors and insulators are commonly used terminologies in the area of electrical sciences. Let us try to know more about them. All the materials in this universe are matter. Matter is defined by its atomic structure. The structure of the atom helps us to define the physical, chemical, and electrical properties of any substance. All matter are made up of the smallest particle in nature called atom. An atom can be further broken down into electrons, protons, and neutrons. The structure of an atom very much resembles the planetary orbital system in which we live. The center is known as the nucleus. It is composed of the positively charged proton and the neutrally charged neutrons. Due to the positive protons, the total charge on the nucleus is positive. The negatively charged electrons revolve around the nucleus in certain circular path known as orbit. They experience a force of attraction by the nucleus. Thus, those electrons which have low energy on them move around closer to the nucleus, while those having higher energy level take up motion paths away from the center. The electron in the outermost orbit thus have the highest level of energy on them. These are very loosely bound to the nucleus and are called valence electrons. According to the valence electrons in a material, the materials can be categorized. The maximum number of valence electrons that is possible is 8. So if in a material the number of valence electrons is less than 4, it is a conductor. If it is greater than 4, it is an insulator. And if it is equal to 4, it is a semiconductor. Now all metals are good conductors of electricity. Coming to the atomic structure of metals, the valence electrons are so loosely bound that they can be easily removed from their atom. Such electrons are known as free electrons. However, each atom can have at most only one free electron. So, a metal which has millions of atoms and hence as many free electrons, when these electrons keep jumping from one atom to another, they do not know to which atom they really belong to. When such a metal is subjected to some electric pressure which polarizes and mobilizes the electrons, thus allowing the passage of electricity. So, what is a conductor? A material that allows free movement of electrons and therefore flow of electricity. Some of the examples of good conductors of electricity are copper, silver, gold, and aluminium. From amongst these, copper is the most optimum choice for electrical installations owing to its affordable cost, good conductivity, and strength. Talking about insulator, a material in which the electrons are tightly bound and there are no free moving electrons, such materials do not allow the flow of electricity through them. Some of the examples of good insulators are PVC tapes, bakelite, rubber, and glass. Until this time, we have known that the free electrons in a conductor, on being subjected to electric pressure, can allow electric current to flow through them. This can be explained with the diagram below. Electric pressure in the form of a battery source is given across the conductors. The negative and the positive end of the terminals polarizes all the electrons in the conductor in a particular direction. This is marked by the black arrows in the figure. Thus, the flow of electron is from the negative end to the positive end. But the conventional current, or the electric current as we call it, is the flow of positive charge in the direction opposite to that of the flow of electrons. This simply can be seen in this way, that the increase in the negative charge on the positive terminal of the battery is a reduction or departure of positive charge from it. The direction of the electric current can be marked with blue arrows, can be seen as the blue arrows passing through the conductor. A voltaic cell arrangement can be looked upon to further understand the flow of electric current and electric potential. A container with an electrolyte solution has two electrodes inserted into it. One electrode acting as anode is the copper rod. Another electrode is the zinc rod, which acts as cathode. The chemical action in the solution makes the electron from the copper rod to rush up to the zinc. This vanishing of electrons and appearance of it on the zinc side happens simultaneously. Now, zinc has acquired a negative charge on it and acts as the negative terminal. The copper, due to its loss of electron, acquires a more positive charge and therefore is the positive terminal of the cell. The negative charge on the zinc will now tend to go back to the deficient copper to neutralize the charges, but this return of electrons to copper will be prevented by the constant force set up due to the chemical action in the electrolyte solution. However, if the two terminals of the cell can be joined by a conductor, an alternative path can be provided for the electrons to flow through them. The flow of electron thus leads to the flow of electric current, or the conventional current, from the positive to the negative end of the terminals. The constant chemical action keeps the potential difference of this arrangement and thus driving the current into the circuit for as long. So the positive terminal is the higher potential and the negative terminal is the lower potential. Concluding from the previous discussion, an expression for electric current can be given. So in the diagram, if we can mark a point of reference on the conductor, then in an interval of time t through a reference point, the current I can be given as the rate of flow of charge Q. So in this rectangular box, which you can see at the bottom of the presentation, we have written the expression of electric current as I is equal to Q by T. Thus, this concludes this video lecture session here. Thank you for watching. For any queries on the contents of this video, please mail me to electroshots.sessions@gmail.com. If you liked the video, please like and share. For further progression from the topics covered in this video, please do subscribe to my channel and press the bell icon. Till then, see you and keep learning.